this episode, I'm going to show you what a SQL injection attack is, along with how it works, and then we'll look at several methods to prevent them. We will also look at how a SQL injection attack can reach far beyond the database. So what is a SQL injection attack anyways? Well, I think it's best described through a series of illustrations at a high level. Let's say that we're hosting a blog. Then Joe user comes along and makes a request to our blog. He asks for example.com/blog/12. The 12 being the 12th blog post. You happen to be running an Apache, PHP, and MySQL application stack. Your blog software queries the database asking for the 12th blog post. The SQL statement will probably look something like this. Select star from blog where ID equals 12. You will notice that the 12 from the URL and the 12 in the SQL statement are the same. This is because we're using user-supplied data to query the database. This can be extremely dangerous if the user input is not filtered correctly. What do I mean by extremely dangerous? Well, if the user input is not filtered correctly, an attacker can execute other SQL statements by playing around with the user input. Let's say, for example, that an attacker comes along after playing around with our blog for a while and notices a SQL injection vulnerability. So the attacker crafts a special request to test his assumption. You will notice that his blog requests obviously look strange. Again, we're using an Apache, PHP, and MySQL application stack. Our blog application takes the user-supplied input and constructs a SQL statement. But what does it look like? Well, it probably looks like select star from blog where ID equals 12 or ID equals 13. That looks weird, but it's actually a valid request. In this example, there is no user input filtering happening, which at the very least should filter out the quotes provided in the user input. You will notice that I played around with the quotes a little bit to make sure that our SQL statement was escaped properly. This is to ensure that it's valid SQL. This is how SQL injection attacks work at a high level. There is actually a really great site called SQL Injection Attacks by Example. I've provided the link in the episode notes below. The site will show you just how nasty SQL injection attacks can be. There are examples to update records, insert new data, delete tables, amongst other things. I got the idea for this episode by watching a YouTube video of a security researcher who was looking for vulnerabilities in a VPN appliance. I highly recommend watching the video. I have provided the link in the episode notes below. I think it is useful because it shows you how an attacker will reverse engineer your infrastructure to find weaknesses. In the video, around the 22-minute mark, a SQL injection vulnerability is found, and the researcher leverages this SQL injection vulnerability to read and write files to the host operating system with an interesting outcome. I was thinking it would be neat to configure a virtual machine with Apache, PHP, and MySQL to see how a SQL injection attack works in real life. Just a word of warning before we jump in. I'm going to configure this server in a highly insecure manner, so don't duplicate my instructions in a production environment. I'm going to be using Vagrant, which we learned about in episode number 4, to configure a CentOS 6.4 virtual machine along with the required application stack. Here is what the Vagrant file looks like if you're interested. I'm just going to log in and su to root so that we can get started. Let's go ahead and disable SE Linux as it stops us from doing fun things, and I will show you why it's a bad idea later in the episode. Let's run get enforce to see the current status. Looks like SE Linux is enforcing, so let's turn it off. We can run set enforce 0 to set it to permissive mode. To make this change persistent across reboots, let's edit /etc sysconfig SE Linux and change the SE Linux line to our desired mode. Now let's install our application stack by running yum install httpd, php, php-mysql, and mysql server. Don't worry about keeping track of all these commands as I've put them in the episode notes below. Now that we have the software installed, let's configure the various bits and pieces. We can start with httpd. Let's run service httpd start to make sure httpd is started. Then we can run checkconfig httpd on to make sure it starts at boot. In this case, we're probably not going to reboot this machine many times, but this is just a habit to make changes persistent across reboots. CentOS 6.4 runs IP tables by default, so we'll have to open up port 80 so HTTPD traffic can get through. Let's open /etc sysconfig IP tables And you will see there is already a rule for allowing incoming SSH connections on port 22. We're just going to copy this rule and modify it for port 80. After saving the file, we're going to run service iptables restart to reload the firewall rules. I always like to verify the rules exist by running iptables-L-N, and you can see that our port 22 and port 80 rules exist. Next, we're going to configure the MySQL server. We can start the server by running service mysqld start. There is a bunch of output since this is a fresh install. Most of this talks about locking down the MySQL server by setting a root password. Let's go ahead and do that by running mysqladmin-u root password and then our new password. Now that we've done that, let's make sure MySQL starts on boot by running checkconfig mysqld on. Okay, so at this point we have a virtual machine configured with HTTPD, a MySQL server, and a firewall rule allowing external access to port 80. But to get the SQL injection bit working, we need to configure a MySQL database and an example PHP script. First, let's log into MySQL at the console and configure an example database with some content. Let's run mysql-u root-p and enter the password we set earlier. I've copied the database creation scripts into the episode notes below so that if you wanted to duplicate my setup, you could. What I'm going to do is create a database called episode 21. Then I'm going to use that database and create an example table called blog. It's a very simple table with an ID and data columns. Then we can input several records into that table to simulate real data. Okay, so now that we have the database created with a blog table and some example data, let's just run select star from blog to verify that it works. We can even simulate what an example PHP script will be doing by doing select star from blog where ID equals 1. This just about wraps up configuring our vulnerable MySQL server, but to aid in the debugging process, I wanted to turn on the MySQL query log so that we can see what's happening behind the scenes when we're doing our SQL injection tests. Let's edit the MySQL configuration file. We're going to enable the general log and specify the output file. After we save the configuration file, we need to create the log file. We need to touch var log query.log and then change the ownership to MySQL by running chown mysql var log query.log. Then we can run service mysqld restart to refresh the MySQL server settings. Then we're going to run tail-f var log query.log to verify the log is actually working. Finally, we need to create our vulnerable PHP script. Let's cd into /var www.html and create a file called blog.php. I'm just going to paste the contents into this file and then we can review what the script is actually doing. This first block here is connecting to the MySQL server on localhost as root and using the password we set earlier. This next block says that we want to use the episode 21 database. These next couple lines essentially take a parameter from the query string and perform a database lookup using data provided by the user. This is also the root cause of our SQL injection vulnerability because we are not filtering input provided by the user. This next block does some error checking. Then down here we return the results to the user, and finally we close the database connection. We created this blog.php script as root, so let's change the ownership to Apache, and verify that it worked. Alright, let's jump over to the browser and see what it looks like. You will notice that I have a browser in the top half and a terminal in the bottom. This is so that we can watch the MySQL query log as we execute our script. You will also notice that I'm using localhost 8080 here, and it's getting proxied to our virtual machine on port 80. This is because Vagrant proxies all the traffic for me. Again, check out episode number 4 if you're interested in learning about Vagrant. Now that we have our application stack configured and the query log going, let's jump over to the blog.php script and try some examples. You will notice down in the query log that a SQL statement was executed with an empty ID parameter. This is because we never provided one in the URL. So let's go back to the URL and tack on ID equals 1. Great, it seems to be working. Now let's try 2 and 3. This is exactly like what we talked about in the beginning of this episode, where an ID of a blog post is provided to MySQL and we try and fetch the content from the database. But you will also notice from our blog.php source code that we are not doing any type of filtering on user input before it's provided to MySQL. Like we talked about in the beginning of this episode, an attacker might craft a special request to test his assumption that a SQL injection vulnerability exists. Let's type id equals 1, quote, or id equals, quote, 3. Sure, this looks odd, but let's execute it. Looks like we were provided with 2 records. Down here, you can see what we were expecting the query to look like, but there is actually this extra bit tacked on. I mentioned the SQL injection attacks by example website earlier in this episode, and you can do all types of nasty things to the database. But an attacker can also leverage the database's built-in functions against the operating system to read and write files and ultimately execute commands. We can use a built-in MySQL function called loadFile to read files from the operating system and return them into a SQL statement. So let's try it out. Let's type 1, quote, union select 2, loadFile, etc, password. Ouch, that's painful. An attacker now knows what users exist on our system. You'll also notice down here what our SQL statement looks like and how we called the loadFile function. But we're only reading files as the MySQL user, so we cannot read the shadow file, for example. But an attacker might leverage this to read PHP configuration or system configuration files to learn about other opportunities which they can exploit. So, what about writing files? Well, MySQL has a built-in function for that too. You can save SQL results into an out file of your choosing. So let's say 1, quote, union select 2, and then we're going to type in a PHP string which we want to write into a file, using the output file MySQL function, which we can then hopefully have the Apache PHP server execute for us. Let's just write this to /tempc.php for now. As you can see down here, the MySQL server happily executed our command. Let's just quickly take a look at that file. Okay, so what about if we have an uploads directory in our blog that allows users to upload pictures or something? Maybe we don't have the most secure permissions. Let's create an upload directory under var www.html and make it world writable. So let's try and write our PHP file using the SQL injection vulnerability into var www.html uploads. Looks like it worked. Our SQL statement took the PHP code we provided and wrote it into a file. Let's head over to the uploads directory and have a look. Our file exists and it works. Let's try and run a couple commands, like ls-l/ for example. Or what about the id command? As you can see, we're running commands as the Apache user now. There is even a more advanced method for executing code that does not require an uploads directory. At the Black Hat conference in 2009, it was demonstrated that you could write shellcode into a file located in var lib MySQL and then have MySQL execute your code. This method does not require weak permissions on your Apache directories and is pretty scary. I think this highlights just how nasty SQL injection vulnerabilities are on any platform, since all you need is a couple lines of bad code hidden away in a large application, and you can own an entire server. We've made many bad choices configuring this server, and you might be wondering what some of the countermeasures are. If I was to propose some suggestions, I'd say first, turn SE Linux on and leave it on. SE Linux will not allow MySQL to write files into var www.html since it is running the HTTPD context, even if the directory was world writable. You should also collect and monitor the SE Linux audit logs as they act as a great trigger. Next, you should never use the MySQL root account for your applications. You should always use role accounts and then limit those role accounts via exclusive grants. And I'd always suggest to disable file access. Next, I suggest you audit your HTTPD permissions to make sure there's no world writable directories. You might notice that these suggestions only limit access to the file system for MySQL. Each platform will have its own issues that you need to worry about. If a SQL injection vulnerability exists in your application, no matter your platform, you're likely in for a bad day. I plan on doing a future episode on ways to filter user input before it even hits your application. But if you have any suggestions, please email me. Alright, that concludes this episode. Thanks for watching. If you would like to get notified about future episodes, please subscribe to my mailing list. You can do this by going to the Get Notified link in the header and entering your email address. Have questions, comments, or concerns about this episode? What about episode ideas? I'd love to hear your feedback, either good or bad. Shoot me an email, justin@sysadmincasts.com.